Hey there, welcome to another episode of FabForge 5. I'm glad you're here. We design and build fun and unusual things, and we always learn something new along the way. This is part 3 of our Spaceship in a Bottle build. Episode 1, we built a bottle cutter and cut our bottle. Episode 2, we got our electronics squared away. And episode 3, we're going to make a bunch of parts now. Laser cut acrylic, we're going to do some acrylic bending, and we'll do some 3D printed parts. Let's get started.
FabForge 5.
All right, let's go back to our design in Fusion 360. I'll show you how we export all of our different files for laser cutting and 3D printing. So first, our design has many different parts. They're both acrylic, 3D printed, and of course the electronics from our last episode. For each acrylic part, we isolate just that part. We look at it head on, and we create a new sketch that outlines that part. You can see it has a bunch of different features: holes for vacuum tubes, mounting holes, slots for the trusses that connect to the large nozzles in the back. We create a new sketch, and for each part for that sketch, we then save it as a DXF file. You'll see that here in a second. Save as DXF. The DXF file is what our laser cutter will use to cut that outline. Now we just repeat this process over and over again for all of our laser cut acrylic parts. Now we need to export all of our 3D printing files. Those are STL files. So for each 3D printed part, we'll select it, and then we'll simply save as an STL. Pretty quick. We'll do that for each part. All right, now we need to create some flat patterns of the parts that we fold with our acrylic bender. So I'll show you how that happens. We're going to activate the flat pattern for our chassis. And that looks like this. It's basically unfolded now. Now the small turquoise lines that you see indicate where the bends happen. We'll come back and see that in more detail. To get a sense of where our chassis fits in the overall spaceship, let's isolate it. You can see it's a pretty important part. It's got to have some pretty precise bends to it. And it holds our vintage CRT at the front for the astronaut to view, and the engines at the back. It has a small slot for an LED. That LED will create a neat light pipe effect. It'll light up the chassis around the CRT. Now we need to create the unfolded drawing or pattern for our base. So the base looks like this, and it'll sit like this, with the spaceship pointed kind of in a slight up attitude. I think that looks kind of cool. So here's how our base looks all by itself. You can see it's got some pretty fancy bends. I always like that honeycomb feature, hexagon feature that kind of mimics some things that are inside the spaceship. Now here's how it looks unfolded. Now it's got these turquoise lines to it. The dotted turquoise lines are the bend lines. The solid turquoise lines are basically the bend radius. So it helps us see how much room that bend will take. We'll export this also as a DXF file for laser cutting. Now one more thing to do, we need to output some STL files for 3D printing for our flexible parts. This will be done with flexible filament. There's a bunch of these, but I'll show you how we do it with one. Same thing, save it as an STL file. All right, let's laser cut some parts. All right, here's all of our laser cut parts. I love the look of an edge that's been laser cut. It's nicely polished and reflective. Laser cut acrylic like this also works great as a light pipe. If you have an LED, it creates a really cool lighting effect. You'll see that in part 4 when we start assembling our spaceship in a bottle and adding our lighting. I built my own acrylic bender patterned after a fantastic YouTube tutorial by Dietec on how to make a DIY acrylic bender. I'll put the link in the description below. The acrylic sits in this space right here, and it folds up like this to bend it. Nice and precise. The heating element is a nichrome wire right here that fits in an aluminum C channel. It's got a spring here because when the heating element gets hot, it expands. The spring keeps it under tension to keep it nice and tight. It's powered by a 12 volt 900 amp landscaping transformer. I found that works really well. Alright, so we'll bend our part with those types of bends. Remember, that's the unfolded part. You can see the dimensions we need to bend. We'll measure it precisely, weight it down, and then we'll turn on the transformer. You can see the spring compressing as the nichrome heats up. It takes a few minutes for a 1/4 inch acrylic, so I'll go ahead and speed it up for you. And I'll turn the lights off so you can see the nichrome warming up. Alright, we'll test it. It's nice and flexible now. Let's go ahead and bend it. I'm going to hold it down, give it a bend. I'll use a protractor to get our 70-degree angle. And then we'll hold it there while the nichrome cools off. For 1/4 inch acrylic, it takes a minute or two to cool. All right, there we go. That's how it looks. The bends come out really nice. 1/4 inch is the largest or the thickest I've tried. You can see the angle looks right. It still has that nice polished look. If you leave it heating on the nichrome wire too long, it creates small bubbles inside the acrylic. You might want that for special effects, but in this case, I don't want that. Now we'll set up for the bends on the other side. 80 degrees this time. Same process. Heat it up, wait a few minutes till it's nice and flexible. Bend it and hold it until it cools. And there's our 80-degree angle. And there it is, all cooled off. Alright, we've got our base. Now the question is, does it fit our bottle? Based on Fusion 360, the design I did, it should fit really well. But we'll give it a try, as long as we've got the angles right. Yes. Right, it fits. Now we'll put some small, kind of translucent silicone pads on the bottom of the base, just to protect whatever surface you're sitting it on. But I think that won't be too noticeable. Right, here's our chassis. We have to bend this guy now. Remember, that's the part that goes inside the spaceship that holds the CRT assembly and the engines in the back. We'll measure it carefully and do the same process. I won't show you all the details of this, but I think you'll get the idea. Make sure it's carefully set up and measured. Heat it up. And then we'll bend it. This one goes to 90 degrees. And I like to put a weight in there that just holds it in place if I can while it cools off. There we go. Now we have to add a second little slight bend for the CRT angle at 5 degrees. We'll do that by placing it this way. And this one we'll kind of bend by hand and an eyeball. There's a finished part. That's our chassis. And we're all good to go now. That's it for acrylic bending. Now let's do some 3D printing. Here are our 3 nozzles that fit in the back of the ship. Now we'll set up our flexible parts. These will be printed with flex or TPU filament. So I've got a few different pieces here. This is the seat. We'll bend that with our acrylic bender. That's the front gasket that fits against the front bulkhead to hold it against the bottle. That's a little strap that holds our USB plug on the bottom of the base. And then we have our 3 thruster gaskets. They hold the rear of the ship against the inside of the bottle. We'll get these set up and start 3D printing them. Go ahead and slice it. You can see how the build will look. This is pretty simple. It's only 8 layers. And we'll export our G-code and start these things printing. All right, here's our print. You can see all the little stringy things on here. That's just a flex filament issue. But this stuff you can burn away with a lighter. It just comes right off. The other thing about flex TPU print is if you use any glue on your printing surface, like sometimes people will use a glue stick to print PLA to make it stick well. The flex sticks like glue itself. So I highly recommend not doing that. You'll never get it off your surface, but now it just peels right off. So here's a nice flexible, I don't know what to call these, gasket, I guess, that'll help push the inside of our spaceship model into the bottle and hold it there. Here's our seat. And so we'll get out our acrylic bender and we'll bend the seat to look something like this. All right, that's how that works. And all this stuff just pops right off. Another thing about flexible filament is that you have to drastically slow down the extrusion rate. Otherwise, the filament basically can't push itself through the extruder fast enough. It bunches up and it will shoot out of this extruder feed port like a big spool of spaghetti and just make a gigantic mess. So drop the extrusion speed rate by at least 50%, and then it sure works just great. All right, so there we are. Now let's set up our astronaut for 3D printing. We'll have the astronauts lay on their back. That seems the best way to do this, but you can see that the astronaut's legs and arms are overhanging. And so based on the way a 3D printer works, there'll be nothing to support those underneath them. So we'll use supports in our print settings. Supports are basically a scaffolding that gets built underneath parts that overhang like that. It doesn't use much filament, and it's easy to break away if your settings are set right. So we'll turn on supports. The astronaut is a model from Not Gonna Happen on Thingiverse. I'll put a link to the model in the description below. It's a nice model. All right, we'll use PLA, probably black for the astronaut. I think that'll look kind of cool. Go ahead and slice it. And you can see how the supports look. They literally are a little scaffolding underneath the overhanging parts. This one's going to be about 249 layers. We'll go ahead and export the G-code and start this print going. All right, let's remove our astronaut. Let's see how this works. You can see it built a pretty big, scaffolding of supports here. It's like our astronaut is sitting on a throne or something, but it usually breaks away pretty easily. Let's see if we can do it. There we go. You get the idea. Now I'll spend a little bit of time and do it a little more carefully. Actually, this is coming off pretty easily. There we go. That's the beauty of supports. They're made to pull off easily, but there's our astronaut. All right, we got a lot done today. We got all of our acrylic parts laser cut and bent. We got our 3D parts 3D printed. And remember, in part 1, we built a bottle cutter and cut our bottle. In part 2, we got our electronics squared away. So now we are ready for assembly. That'll be next time. Looking forward to seeing you again. If you enjoyed this video, please like. And so you can be sure to be notified when the next video is ready, please subscribe. And until then, just take good care of each other. I'll see you later.